Welcome back, everyone. Houston Math Prep here. We're going to talk to you about graphs of exponential functions, finding domains, ranges for exponential functions, and also doing some transformations of exponential graphs. So here I have a basic exponential graph, y equals 2 to the x. Remember that we said in our last video that a basic exponential function is going to have the x-axis as a horizontal asymptote. We might also want to write our asymptote as an equation, so remember that the equation for the x-axis is y equals 0. So our horizontal asymptote in this instance is y equals 0. If we look at the domain of this, there are a couple of reasons why the domain is any real number. So first of all, if you think about what's going on the graph, we could keep plugging in values and getting closer and closer to the axis if we wanted forevermore. We don't really see the right side of the graph much here because this graph gets tall so quickly. So it is continuing up and to the right forever. We are going to get graph to the right forever as we go off the edge of the page here. But one way to really understand domain is to think about what numbers can we plug in for x. Can I plug in any positive number? Well, sure, I can take any positive exponent I want. I can do fractions, I can do whole numbers, I could do really big exponents, I'd get really big numbers, but I can do any positive number I want. I can take any negative exponent that I want. That just means take the reciprocal, right? So I can plug in any negative number I want in an exponent, and I can also take an exponent of 0. So in a function, if I'm allowed to plug in any positive number, any negative number, and 0, then that means I can plug in any real number, right? That's all the possibilities we have on the number line. So the domain is negative infinity to infinity, or in other words, it's all real numbers. Now the range, if you notice the y values that we're going to get out of this graph, the graph never goes below the x-axis, right? In fact, it doesn't even touch the x-axis. So we're not going to get any negative numbers for our y values on the graph. We're also not going to get 0. We get really close to a y value of 0, this asymptote, but we don't actually touch 0. So we're actually only going to get y values on this graph that are everything above 0, all positive numbers. So we would say that the range for this graph, all of the possible y values we get out of the function, would be 0 to positive infinity, everything greater than 0, in other words. We want to real quickly just remind you of the system that we use to discuss transformations of graphs. So we have IHOD and we have OVER, and remember that IHOD is saying that when there is a change inside the operation that gives the graph its shape, that is going to give you a horizontal change. That change will be opposite what you see, and that change may affect the domain. If you have over, that's the other part of our system. Remember, over tells us that if the change to your function is outside of the operation that gives the graph its shape, that's going to be a vertical change. That change will happen exactly as we see in the formula, and it may affect the range. Let's look at an example here. I have y equals 2 to the x plus 3. Now the first thing I notice is I'm adding 3. I'm adding 3 outside of the exponential. This exponential is what gives the graph this particular shape. Since this is outside of the operation 2 to the x, then we are going to be in an over situation. Outside means over. Well, over tells us that it's going to be changed vertically, and it will be changed vertically exactly what we see. So if we're adding 3 to everything vertically, then the graph of y equals 2 to the x will be shifted up 3 units to give us the graph of y equals 2 to the x plus 3. So if I pick 3 of my points and I move them up, so let's say this 0, 1, if I move that up 3 points, that's going to give me 0, 4. If I take my 1, 2 point here and I move that up 3, that's going to shift to 1, 5. And then if I take 2, 4 and shift up 3, that will give us 2, 7. The equation of the asymptote, if we move the entire graph up 3, we wouldn't be at y equals 0 anymore. I would take this asymptote and I would shift it up 3, and that's going to give us that our asymptote will be at y equals 3. When I'm trying to decide on the domain and range, and if there are any changes to those, I think about over, and over tells me that my range may be affected by this change. So my domain stays the same as it usually is with an exponential function. It will be from negative infinity to infinity. The range will be changed because now if my asymptote is at y equals 3, that means we moved everything up 3 from where it was previously. So this will be my graph of y equals 2 to the x plus 3, and that will mean that I get only graph above a y value of 3, so my range will be from 3 to infinity. Looking at our next example here, y equals 2 to the x minus 4. So again, this minus 4 is outside of the exponential that gives the graph its shape. This is y equals 2 to the x, and this is outside of that operation. So this will again be an over transformation. So we have an outside change that will change the graph vertically exactly as we see. So it will have a vertical change minus 4, which means that everything will shift down 4 units. If we're shifting down 4 units, let's go ahead and state some points. So my 0, 1 moving down 4 units, that would move the y value to -3, so we'd have 0, -3. If I take this point 1, 2 and I move it down 4, then we'll be at 1, -2. And if I take this 2, 4 and move it down 4, we'll be exactly on the x-axis, so we'll be at 2, 0. Think about now moving this asymptote down 4 as well. So instead of having the usual y equals 0, moving this down 4, our asymptote would be at y equals -4. We have a new horizontal asymptote there. Since we are using an over transformation, this may affect the range, not the domain, so our domain stays the same and it's -infinity to infinity. But now if I look at the graph of this y equals 2 to the x minus 4, you'll notice that I have graph everywhere above y equals -4. In other words, between -4 and infinity. If we look at our next example, y equals 2 to the x plus 1, where the 1 is in the exponent. So now the 1 is actually inside this operation of an exponential that gives the graph its shape. So this will be an IHOD example here. So our change is inside. That will have horizontal changes, and they will be opposite what we expect. So if it's a horizontal change and it's opposite, this plus 1 really is going to be a -1 change horizontally. So if we look at a -1 change horizontally, then that is actually going to move the graph left 1 unit. So our graph of y equals 2 to the x plus 1 will be the same as this graph of y equals 2 to the x, shifted left 1 unit. If we look at some of our points here, let's look at 0, 1, and we move that over 1, then that's going to be at a point -1, 1. If I take 1, 2 and move it over to the left 1 unit, that would be at 0, 2. And if we take 2, 4 and move it over 1 point, that would be at 1, 4. The equation of the asymptote, think about if I take this asymptote and I slide it sideways, am I really changing where it is? No, it actually is going to stay in the same place, right? If I move this horizontal line up or down, that's going to change its y equals equation, right? So we're not actually going to change the equation of our asymptote. It doesn't move if we slide left and right. So our equation of the asymptote stays y equals 0. When we look at domain and range, remember that we're using an IHOD transformation, so our change here may possibly affect the domain. It's not going to affect the range, so we will keep our usual range of 0 to infinity. Now the domain, think about what's happening to the graph as we move over 1 and we plot these points and draw our new version of the graph. Does the domain change? And the answer is no, it really doesn't, because I can still plug in any positive or negative number or 0 to this and I'm still fine. So our domain here is still -infinity to infinity. Remember, when we say that we might affect the domain, that's not a guarantee that we will affect the domain and it will be different. Here's another example of a change in the exponent, y equals 2 to the x minus 3. So this change is inside the operation that gives the graph its shape. So this will be an IHOD transformation. It will be a horizontal change opposite what we expect. So if this is a horizontal shift, it should be opposite of -3, which would be +3, and a horizontal positive change would be to the right. So this will shift to the right 3 units. If I take some of my points here, let's say 0, 1, and I move it over 3, that will put me at 3, 1. If I look at 1, 2, and I move it over 3, that will be at 4, 2. And if I take 2, 4, and move it over 3, that will be 5, 4. If we take our asymptote and simply slide it sideways, it's not going to actually change the location of the asymptote. It will be moving along itself. So our asymptote stays at y equals 0. Since this is an IHOD transformation, it may possibly affect the domain, but not the range. So we will keep the range of a regular exponential function, which is going to be 0 to infinity. Now, if we're trying to decide if this shift right 3 units affects the domain, first let's plot our graph here. So we slide everything over 3 units. It includes these points. Here's our asymptote in the same place. does this have a different domain? Is it no longer negative infinity to infinity? And because our domain is usually the entire real number line, it doesn't matter if we slide it over on the number line left a bit or right a bit, we're still going to get the entire number line, right? So our domain stays the same here. We can plug in any x value we want to this function. Our next example here, we have y equals 3 times 2 to the x. So we're multiplying by 3, and we are multiplying outside of the exponential operation. So we're multiplying outside means this is an over transformation. We will get a vertical change and will be exactly what we see. So we'll have a vertical change of multiply by 3. So that means vertically everything will be 3 times as tall from the axis as it normally is. So we will have a vertical stretch by a factor of 3. Everything will be 3 times as tall. If we state 3 points, let's go ahead and look at, so say 0, 1 here. If we multiply that by 3, we'll get 0, 3. If we take 1, 2 and multiply that y value by 3, then we'll get 1, 6. If I try to take 2, 4 and multiply by 3 and I graph it, well, that'd be up at 12, which is off the edge of my page. So let's go ahead and take this point maybe negative 1, 1/2. If I multiply 1/2 by 3, then that would be 1.5, also known as 3/2. So we get negative 1 3/2. Let's say if we stretch that point taller by a factor of 3. If we stretch everything taller, does our asymptote move? Well, our asymptote is at a height of 0, and if I'm stretching away from the axis, it doesn't really move. It stays at the axis. So we're still going to get an equation of y equals 0 for our horizontal asymptote. This is an over transformation, so it may affect the range, but the domain is going to stay what a usual exponential function has, and it will be negative infinity to infinity. If we think about affecting the range is usually from 0 to infinity. If I can extend forever upward, it doesn't matter if I multiply those numbers by 3. Think about getting really, really tall, going off towards infinity. What's 3 times infinity? Well, it's still just something really, really big, right? It's still infinity. So our range isn't going to change on this one either. We'll get some points that are stretched upward. You can see it looks like our exponential graph is growing more quickly because of the multiply by 3, but our range is going to stay 0 to infinity. Let's look at 2 more examples. We have y equals negative 2 to the x. So having a negative out front, remember that negative is not part of the base. That's just like multiplying by a negative 1 out front. Since that's like multiplying out front of the exponential, that's going to be an outside change. So this will be an over transformation. So we will have a vertical transformation, exactly what we expect. If we multiply by a negative, that's not stretching by like a factor of 3 where we multiply by a 3 in the front. If we multiply by a negative, that's going to change the signs of all the y values. So our graph is going to be transformed by reflecting vertically across the x-axis. So if we think about transforming some of our points and we want to find where those are, think about 0, positive 1 reflected below the axis is going to be at 0, negative 1, and 1, positive 2 reflected below the axis is going to be at 1, negative 2. 2, positive 4 would reflect below the axis and become 2, negative 4. If I reflect my asymptote across the x-axis, it's not going to change. Imagine this is a piece of paper and we have this, and this is our line of symmetry, and we're folding along this line, and we're going to fold this over this line. Well, nothing on this line is going to change because it's on the line of symmetry, right, if we reflect it. So our equation of our asymptote is going to stay the same, y equals 0. It won't change. Since this is an over transformation, we know that it won't affect the domain, so the domain for this function will be the domain of what basic exponential functions are, negative infinity to infinity. And my range is normally 0 to infinity, but if I reflect down here and look at the new graph, then I'm going to not get all the positive numbers for y on my graph. I will have all of the negative numbers for y on my graph. So the graph of y equals negative 2 to the x, all of the points are below the axis. That's going to be all the negative numbers, everything less than 0. So our range in this case will be from negative infinity to 0. Our last example here, y equals 2 to the negative x. Now we have negative multiplication in the exponent. So think about this is a multiplication by negative 1 inside the operation that gives the graph its shape. So inside means this is an IHOD transformation, and the change will be horizontal. So multiplying by a negative 1 here Horizontally, we will reflect, so we'll be reflected horizontally, so not over the x-axis this time, but will be reflected across the y-axis. Left will become right, right will become left. So if I think about taking, for example, 1, 2, and I reflect it across the axis horizontally, that will give us -1, 2 will be in quadrant 2. This 2, 4 point, if we reflect it across into the other quadrant, that would be at -2, 4. And let's look at maybe one of our quadrant 2 points. Let's look at -1/2. If I reflect that horizontally, it's going to move over into quadrant 1, so we would then be at +1, 1/2. The equation for the asymptote, if I flip everything horizontally, then my asymptote is going to not change as well, right? Think about if I fold this part of the asymptote across, it's going to become this half. And if I fold this half across and reflect it, it's going to become this half. So we get the exact same picture, at least as far as the asymptote is concerned, when we do our horizontal reflection. So we will still have an equation for the asymptote of y = 0. If we think about how the domain and range will be affected, this is an IHOD transformation, so the domain may possibly be affected, but the range will not. So the range will be the same as a typical y = 2 to the x, a basic exponential function, which is 0 to infinity. Think about if we have all of the points above the axis and we flip this horizontally, then we're still going to have all of the points above the axis. We will just have the graph reflected and changing in the opposite direction. So now, does this affect the domain? It does not affect the domain. We should get all of the graph. We get everything from -infinity to infinity. As far as x goes, I can still plug in anything into the exponent, positives, negatives, or 0. So we get a domain of -infinity to infinity for this as well. Okay, hopefully this gives you some help with your exponential function graphs, finding domain, range, transformations using IHOD and OVER. Thanks for watching, everybody. We'll see you in the next video.